So good afternoon. Thank you for coming. I am Ronan Baron. I am going to present to you the next generation of smart electrochemical gas sensors from Alphasense. So the A+ and B+ series. So Alphasense has been around for 25 years. And we have about 130 employees, all based in the UK. We say the company is based on innovation. Actually, we have made quite a few developments in gas sensors for safety and for air quality. And we are now in an exciting time where we are part of the Ametec family. So I'm here today to present you with the new A+ and B+ sensor series. You will recognize on the pictures that we actually have the standard sensors from Alphasense, the standard gas sensors in the standard format, but to which we have added a small sensor chip. And the sensor chip does contain a memory and a temperature sensor. So the beauty here is that we were able to integrate that sensor chip completely in the base of the sensor in such a way that we keep the external dimension, we keep the same format, sensor format. Now, what we want to put in the memory, well, we have different fields there of data. We want to put specific sensor information. That includes the sensor type, serial number, manufacturing date, warranty period. We want to put sensor specification data, general data, like temperature compensation or what the concentration range is for that sensor. Calibration data, of course, that's probably the main thing. We calibrate the sensor on site. We want to put the zero sensitivity, cross sensitivity. And then we also have a field for customer specific data, where we will put a customer-specific secure code, and also there will be space for customers to put their own data if they wish to do so. So what is the benefit now of this sensor chip? Well, first, of course, we want to give the benefit to our customer from the calibration we did. So maybe you could skip the calibration phase. Maybe you don't have necessary to buy expensive calibration gases, and that will save money, time. The other benefit here, coming from the fact that we have a compatible format, is that this sensor can be placed in existing instrument. Maybe the electronics needs some changes to be able to read the memory, but actually the format is the same. It also means that if somebody uses these sensors, they will still be able to use competitor sensor for second source. They will have to do the full calibration like they have to do it now, but at least it's possible. Another benefit here is when we do servicing. So if we do servicing, of course, you could think about an instrument that needs a sensor replacement, and therefore you would open the instrument, you would change the sensor. The sensor has already the preloaded calibration data. You close the instrument and it's ready to go. So that's particularly important if you have instrument in remote places. I took there the example of a tanker ship. Maybe we don't have gases for calibration there. And maybe it's very good to have a replacement sensor ready to go. I have to say that now the electronics that you have, if you adapt it to be able to read the sensor data, you could also now think about going a step further and having your electronic to really adapt to the sensor you use. That means that what I mean by this, and I will take an example. Imagine you have an H2S monitor, and actually you open the monitor, you take the H2S sensor out, and you put a CO sensor instead. Well, the electronics and the instrument will be able to know from the memory that this is now a CO sensor, what the range is, what the concentration range is, what the cost sensitivities are, what to apply for temperature correction, what bias to apply. Basically, what will happen is that when you change the sensor, your monitor now that was an H2S monitor will become instantaneously a CO monitor. So what it means that you can develop universal electronics. And when you change sensors, you don't need to change the settings manually via software interface or anything like this. Basically, it will make the process simpler and more secure. Now, having a sensor chip onto a sensor is a bit like having an ID card attached to the sensor. So it means that you will know that this is a genuine Alphasense sensor. You will know that this sensor has not remained in storage for too long. And the benefit is that actually, if you use sensors that are controlled in such a way, your instrument will work to its optimal conditions. Actually, you can use that principle also for if you wanted to lock your instrument to a specific sensor provider. So if you are in a situation where you make instrument, probably you have an after-sale market, which is very valuable. And you can make your instrument to take only the sensors that you sell to your own customer. You can lock your instrument to this. And there is also space of memory still available in the chip. That really means that on this ID card you can add things. You can actually write things like how much sensor usage has been, what the maximum concentration is, what the temperature was that the sensor has experienced, the highest, the lowest. That means that when you get a sensor back, if you get a sensor back from the field and somebody has changed the sensor, you could actually read the sensor and understand what the usage is, what people have done with the sensor. Now, if we talk about air quality applications, so typically Alphasense does quite a lot of work with people who do air quality measurements. And there, what you have things like the concept of smart cities, where you have a lot of instruments spread out in a city. Well, it's actually quite a work, and I know by experience because we did some tests ourselves at Alphasense at putting box and spreading box around Heathrow Airport in the UK, that it's quite difficult actually to follow which sensor is where and which sensitivity you have to apply to which instrument. Well, here, of course, that makes it here much more easy. The management of this big network would make it much simpler if we just replace a sensor. Each instrument deals with the specificity of each individual sensor automatically. So at the end, you get a more efficient management. Again, you can save in cost and save in efficiency. We have put also a temperature probe. For air quality, it's very, very important to really try to correct really precisely the temperature for algorithm. And having a sensor close to the sensor mass rather than the airflow will give you a supplementary information that you can use for this corrections. So I just wanted to say something about how we dealt with this project. And the first thing was really, we wanted to do something like a digital electronics for sensors. And we were, but thinking about it and rethinking how the sensors are used and what can bring value to the customers, we ended up thinking actually just adding a memory, adding a temperature sensor is bringing a lot of functionality without adding very, very much cost. So you don't have to have a half instrument in each of the sensor, because that adds too much cost afterwards. Here, what I've been trying to tell you just before was that this can bring value throughout the value chain, making processes simpler, more efficient, less costly, and more secure. And what we claim here is that we redefine what a smart sensor is. So a smart sensor means also not adding too much cost. We argue here, but keeping the added functionality if we can. For those who are interested in knowing what is on the chip and how it's made, we use a 16K EEPROM, 12-bit degrees Celsius temperature probe, and both share a nice I2C high-speed serial communication interface. We intend to use a digital signature to make sure that the data is transferred in its integrality from our calibration data to the chip, to the memory. So we also provide the schematic drawing. Here you can see there is two pads we are having for the power supply and two for the I2C serial communication. The circuitry is protected for electrostatic discharge with diodes here, and also protected against power transients with some capacitors. So we provide, we have made a simple board which does have an interface of both for the sensor output and another interface here for the digital output coming from the memory, from the chip. I wanted to say just a word saying that we use spring contact to the chip, and it works well, and you can see by yourself. We have an example. We have, because we were able to manage adding the chip to sensor bases, existing sensors, it means we have streamlined our process at Alphasense. It means all our sensors now, the A and B size, will have a recess in them. And at the end of the line, when we come to chip the product, we can add the memory into it. That means that you get a huge number of sensors available right away in this A+ and B+ format. And it means that we were able to work without adding too much cost to it. So I will give some space for questions, but just I wanted to say that Alphasense is bringing two more new products this year. One is a leak-free oxygen sensor. This is a galvanic lead sensors. Everybody knows that they work a bit like batteries, and it's very difficult when sensors leak. Here we work really extensively on this to be able to produce a sensor that is leak-free. We actually believe that there will be still a lot of people using lead sensors for a few more years. And we also have introduced a new sensor format, the H series, again with quite a number of variants available. So, so I went through my talk, but now I welcome questions. We actually have still 10 minutes for anybody if they wanted to ask anything or discuss anything. I'm happy to engage. Also, to let you know, we have a stand. This is in the stand 1-205, so in all one. And anybody would be welcome to visit us as well there. Right. Thank you. Thank you for your attention. Thank you. It is the first time I talk in a hall in an exhibition. It's a very different feeling than in an amphitheater, or there's noise. There's you have to go through. It's like a marathon. You know, you have to go through your talk. So, but please, we are in an informal place. That means informal questions are welcome. Please, Klaus.
Yeah, thank you. I have a question concerning the leak-free electrochemical sensors. Yes. Leak-free means that do you have special membranes to prevent the sensor from...
That's a very interesting question. So we have just done a patent application, and it's just the way of handling that sensor. So I can't answer your question. I prefer to tell you first, but still I can discuss a little bit the subject. Really, when you have lead sensors, they oxide, you produce lead oxide. This takes a lot of space, and so you create pressure inside of an enclosure. And so trying to block that in is very, it's very dangerous, because if you block pressure, internal pressure, you could actually have your sensor cracking and then leaking even worse. Okay. So we had to find a balance and try to find how can we create those conditions where we can relieve pressure, but not at the same time not having leakage. Yeah. Okay. And so, so Klaus, I cannot answer you. Next year I will.
Yeah. Okay. So, but the benefit, actually, to summarize that, is to your clients is that the lifetime is, for example, larger.
So the lifetime of a lead sensor is those ones that the one that I show is 2 years. We also have a variant for 3 years. Okay. That's because you don't have lead left afterwards. The lead is a fuel. But then while you are using that lead, you don't want this leakage going onto your electronics. Okay. And so it's important to control that, to stop the leakage going on. I think for as long as I've been in industry, 14 years, I have every year heard about people complaining about this lead sensor leaking. So we really wanted to do something a bit better.
Okay, so thank you.
Thank you very much. I think talking about smart sensors is there's a risk to add cost, basically, and I think if sensors are replaceable, adding a bill of material of 20-30 pounds onto a sensor is a bit problematic, especially for us when we do high volume. Then there is also the question of how much quality you can put in that circuitry. We want to deal with very high quality circuitry, low noise, capable circuitry. Otherwise, you don't get the benefit of very fine sensors. So this is how we were thinking about just adding the memory. Actually, the memory does have lots of benefits already. Yes. I think next speaker will have 5 minutes to put his things in order before, if he's here, the next speaker. I don't know. Yes. So I think you're welcome to come, and we thank you so much for attending. It's all nice to see you there. Sorry for the noise, but